Okay, for 2A students to prepare for your exam, so I would like to explain some of the questions in your workbook. So if you have your textbook, you can go to page 123. And if you have a workbook, you can go to page 56 here. Okay, so I'll start now. So I want to let you know that this is about 8.6 for some household electricity. How you understand about your electrical appliance at home. Okay, for example, on the right hand side, mains electricity is generated in power station. This one. Okay. I'll explain them with the answers. Okay, because I've given you the answer, but I just want some explanation. So they are generated in power station and later transmitted to our home. Here. Okay. And the statement 1 is correct. For statement 2, the mains voltage in Hong Kong is 220 volts. You can refer to here. This is page 124. Whenever I want you to work on true or false question and the multiple choice question, I want you to tell me which page you can refer to. Okay, textbook page 124. Or write down the solution. Y is correct, Y is wrong. 220 volts. Yeah. Okay, 主要嘅電壓。So question 3. The sockets in the home are connected in series. Okay, you can see. Question 3. Socket at home. We connect it like B. As you learned in lesson, so we understand that we call this in parallel. Connected in parallel. That means there are multiple branches. Like branch 1, current can pass through branch 1, branch 2, and branch 3. You remember these? When we, okay. When we try to connect branch 1 and branch 2, these two light bulbs can be light on. Branch 1 and branch 2. But then open the switch on branch 3 does not affect the other two light bulbs, so that they can work independently. 佢哋互相唔受影響嘅。Therefore, you should correct this in parallel. In parallel. Therefore, statement 3 is wrong. Statement 4. Electricity is supplied to our homes through live wire and earth wire. This is wrong. How do we transfer our electricity? Basically, you can refer to this one. Okay. So for example, in a kettle, 電熱水煲, you heat up the water here. So electricity is the current pass through live wire and neutral wire. They form a complete circuit. Okay. Therefore, I want you to write down the wrong answer is earth wire here. You should say this should be neutral wire. Okay. Live wire and neutral wire forms live wire and neutral wire forms a complete circuit. Forms as closed circuit. We use this term, form a closed circuit. Okay. If you want to take a look, then this is page 128. Page 128. Okay. So I will go down to the next one. For the next part, refer to page. When you refer yourself to the textbook, you will understand how to work on it. So there are three pins and 3 holes in the socket and the plug. So the top one 好似一個中文品字形咁嘅。Okay, the top one we call it earth pin and earth hole. Pin is the thing that poked out. 突出嚟嘅。Hole is the position where the pin insert into. Okay. So you imagine this live pin is on the left hand side. When it's inserted to the right hand side. Therefore, it's the live hole here. I should use, okay, let me use the brown in color. Brown color here. It looks brown here. Therefore, on the left hand side of the pin, this is live pin. On the right hand side of the hole, this is live hole. Get what I mean? So the next one. On the right pin, this is neutral pin. Therefore, it's inserted to the left hole. Neutral hole. Neutral hole. You can refer to this page on your textbook. So later on, when we want to open this kind of plug, you will see this picture. So how do we study this 3-pin plug? We insert it, refer to textbook page 127. So just now you understand that the top one is the earth pin. It's the earth pin. It's usually in yellow and green color. Therefore, we call this earth wire. That wire, we call it earth wire. And for your neutral pin looks like blue in color. Okay. Neutral. You flip it back, like 調轉佢嘅，反翻轉嚟睇咧，我哋而家係睇緊個 plug 嘅背脊。So we are looking at the back side of the plug. You will see this pin comes to neutral wire on the left hand side. We turn the plug backward. So the left hand side is a neutral wire. And the remaining one is brown in color. We call this live wire. It's connected to the fuse. Always connected to the fuse. Here. Okay, just some textbook knowledge. So this time, to some level 2 question, this is more difficult. You have to understand them with some effort, not just to refer to the textbook. So which of the following electrical appliance use the heating effect? You imagine which appliance need to produce heat. For example, in your toaster, yes, you produce heat. Kettle, electrical iron, you need heat. Electrical kettle also, yes. Okay, so the answer should be 1, 2, and 3. Okay, so next one, question 2. Which of the following uses the magnetic effect? Whenever we say magnetic effect, it produces some movement. Let me write down here. Produce movement. For example, electric fan, they move the air, their blades try to produce movement. Vacuum cleaner also produce some wind. Therefore, they produce movement by magnetic effect. Whereas rice cooker, we want to cook the rice, it is the heating effect only. Heating effect only. Okay, so the answer is B. Next one. So also refer to textbook page 127. When you learn in class, you should have jot down the notes here. So for live wire, it is brown in color. Neutral wire, just now I used the color blue in color. For earth wire, we use green and yellow. You have to pay attention that always the live wire is connected to the pin, to the fuse. Okay, therefore you should be able to write live wire. So for the next part, we refer to next part of your textbook. Next part, part E, 8.6E, 8.6F, and 8.6G. So from textbook, page 129, here. Okay, number 1, when too many electrical appliances are connected to the main socket, too many of them, we call this overloading. What is overloading? Let's see. That means you connect, well, too many electrical appliances, too many plug to the same socket. Therefore, there's too much electrical current there. So we call this overloading. Okay, question 1, overloading. Question 2. The device shown on the right hand side. This one. See the name below. The name below. We call this universal adapter. When you refer to the textbook, you know how to work on these simple questions. Okay, so next part. There are some safety design to protect the circuit. For example, this is a fuse. What is a fuse? Usually, there is a metal wire with low melting points. When the current is too large, the heating effect will be very strong. So melt the wire and break the circuit. Okay, so you understand the function of this fuse when the current is too large. So we call this the fuse. This is a fuse. Okay, textbook page 133. This is a fuse. It has a metal wire with low melting point. The number on this fuse, how do we call it? So I just want you to be able to look for an answer on your textbook. Okay, the number printed on the fuse is called the fuse rating. Fuse rating. Fuse rating. Okay, but then the fuse, when it's broken, when the metal wire has been molten, it cannot be reused. So for the next one, we have something that can be reused. For example, this is a circuit breaker. Circuit breaker can break the circuit when the current is too large. But then this is reusable. We can turn it to off mode. We can turn it to on mode anytime we want. Okay, we call this the circuit breaker. Next part, true or false. So for overloading and short circuits, why is it dangerous? Why do you know why they are dangerous? Because they are, okay, let me go here. When there's short circuit or when there's overloading, very often you may produce lots of heat due to the large current. And this can damage the electrical appliance. So this is dangerous and we should avoid it. So this is true. Okay. So the second part, fuse and circuit breaker can reduce the risk of circuit overheating. Circuit overheating. When the Okay, let me find the correct part for you. If the current is too large, the fuse will blow and cut off the circuit current so they prevent from overheating. Sometimes when you don't know the answer, I hope you can really refer to your textbook and look for the answer. They prevent the overloading, they prevent too much current passing through, therefore preventing circuit overheating. Okay, next part. Also, page 135, you can read this line. A suitable fuse should have a rating just a little, just slightly higher than the normal operating current. Slightly higher than the normal operating current, so that when the appliance have abnormally high current, this fuse can be blown out and it can break the circuit to protect the appliance. 當嗰個電器咧太熱嗰陣咧，太大嘅 current 啦，太熱嗰陣咧，佢就可以防止到佢會燒咗個整壞咗嗰部電器啦。So this one, this is false. Question 4, also wrong. The fuse cannot be reset. After it blows, it is no longer useful. Cannot be reset or cannot be reused. So you have to buy a new one, buy a new fuse, but it's actually very cheap. You can just buy a new one. Okay, so also for the normal operation, you should understand here. For the normal operation, there's current passing through the live wire and neutral wire only. Okay, live wire and neutral wire only. It does not pass through the earth wire. Does not pass through the earth wire. They do not carry current under normal operation. So how is earth wire useful? And how is current useful as the case when there is some damaged live wire touching the metal case. Therefore, we want to prevent such kind of electric shock with the current passing through our body. This is very dangerous. Right? How do we prevent this accident? So by adding some kind of earth wire here, denoted by E. So they provide a pathway for those damaged live wire, those current, they can pass through the earth wire, and so that they will not go through our body. Therefore, And this part you should be able to underline earth wire and cross it. Only live and neutral wire carry a current. Okay. So I'll quickly go through the next part. This is level 2. The fuse rating is usually marked in the fuse rating. They just want to limit your current, your size of your current. Therefore, the answer is, okay, I'll show you the answer first. They want to limit the current, therefore it's marked in ampere. Okay, unit ampere. Question 2. The fuse of a 3-pin plug should be connected to the live wire, as we said before. Okay, should be connected. Let me see. You can see from page 127. Page 127 should be connected to the live wire. So the vacuum cleaner normally works with a current of 9A. With a current of 9A, 9 ampere. If you just use a 5A fuse, the size of current allowed by the fuse is too small. Is too small for this vacuum cleaner. Therefore, that vacuum cleaner have to use a 9A current. This is too large for the fuse. The fuse will blow, the cleaner cannot operate. So the answer is B. Last one, the earth wire and the 3-pin plug. What is the function? It functions when the damaged wire, live wire, touches the metal case, so it prevents the electric shock in our body. The earth wire provides a pathway for this unwanted current. Therefore, we will choose A as the answer. Short circuit is here, short circuit. So in this old electric fan, there's lots of dust. When dust may contain something that conduct electricity. So we call this short circuit. Short circuit may cause some dangerous situation. For example, when there's too large current the current is too large. And this can cause the overheating and damage the fan. Somehow, overheating may cause fire as well. May cause fire too. Okay, how do we prevent this danger? So we should keep the fan clean and dry. No moisture, no water around. Clean it. Next part. Okay. Okay, so the diagram below show how the electric iron is connected to the main socket. So we should say that wire J is a neutral wire, whereas wire K is a live wire. Okay. Because in the wire J, there's a neutral wire. Neutral wire is sometimes connected to a switch. Last page. Name the circuit component. Okay, I should erase it. Wire J should be live wire, and wire K should be neutral wire. You should correct the answer. This is the correct answer. For component P is the fuse. Fuse should be connected to the wire J, live wire. Symbol of fuse, you should draw like a box and a straight line passing through. Okay. So the normal operation current is 10.58. We should choose a current we should choose the fuse rating that's slightly higher than 10.58. So we choose 13A. Last one. So the user will, after some repeated use, and the insulation at Y may be worn out, may be broken. So that electricity, that current may be passed to the metal case. Therefore, the user may get an electric shock. And so we should draw an earth wire to protect the user. How to draw this? We should draw to connect the metal case to the earth plug. Okay, the last part you can refer to the answer here. We should not cover electrical appliance at work. Let the heat go away. We should not overload the socket. We should use these electrical appliance with a dry hand, not a wet hand. So if you have any question, you can ask me. And wish you study hard in your exam.